Okay, let's pop right into chapter 5. It's October 1774. These two titans of chemistry, Joseph Priestley and Antoine Lavoisier, are still meeting in Paris. And Lavoisier continues speaking to Priestley, saying, "This air, you called it fixed air. It's produced by the reaction of baking soda and vinegar. It's what we breathe out. It's what fire emits. This air also extinguishes fire. Mice, ants, and humans cannot breathe it in. As we said, we all breathe it out. You have determined all of this. And if phlogiston is a thing, this air is phlogiston. Excuse me, phlogiston is a universally accepted of fire and combustion. It is a thing." Joseph Priestley fires back, visibly disturbed that someone would doubt this theory. "Oh, I do not doubt this, my friendly English gentleman, but a question does arise to which I'm sure you have the answer. You discovered oxygen by heating mercury calc in a vacuum, an amazing discovery. And the equation for this is mercury calc, when you heat it in a vacuum, decomposes into pure mercury, metal, and oxygen gas. But if you reverse this process, which you can unite mercury and oxygen and get the mercury calc back. So mercury calc, according to this equation, is comprised of mercury and oxygen. But you also say when heated in air, you get this equation. So mercury, when heated in air, becomes mercury calc, and phlogiston is emitted. This is all very confusing to me. How can equation 2 and equation 3 both be true? And one final question I pose to you: if phlogiston is a thing, and I know it is, what is its mass? If it exists, it must have mass. When it is released from metals, when they're heated, I'm sure the metal must lose mass. If metals have phlogiston, you heat them and they release the phlogiston, the metal itself, the remaining residue metal, should lose mass. Can we test this?